When doing curvilinear motion, especially with polar coordinates, you will probably have to do a few time derivatives. I'm going to quickly show you how to do this with a few examples. The main principle behind it is the chain rule from calculus. So let's say you have an equation like this. Now we are going to take the derivative with respect to time. Another way to think about it is implicit differentiation. First, we take the normal derivative of this equation and then you multiply it by the time derivative. So for the left side, we have dr over dt. For the right side, we have the derivative of 40 cosine theta, which is negative 40 sine theta. Then we have the derivative of theta with respect to time. The d theta over dt can be represented by a theta symbol with a dot on top. The r with the dot on top represents dr over dt. This is a recap of what the dots on top mean for r and theta. Doing a few more examples will help you understand this better. Here we have another equation. As before, we take the normal derivative and then multiply it by the time derivative of theta. Now let's say we need to take the derivative of this again, so the second derivative. It's the same process. But notice how we have a product of two functions. So we now need to remember the product rule from calculus. The product rule says the derivative is equal to fg prime plus f prime g. So assume this section is f and this section is g. So we leave f alone and take the derivative of d theta over dt, which gives us d squared theta over dt squared, which is represented by theta with two dots on top. Then we add the derivative of our first equation, which gives us negative 400 cos 2 theta multiplied by d theta over dt. And then we multiply it by the g equation which we left alone. This is an easier example. When we first do the normal derivative, we get 0.4. Then we multiply it with the time derivative of theta. The second derivative is the same. The normal derivative gives us 0.4, and the time derivative of theta gives us theta with two dots on top. Let's look at another example. Let's do the first time derivative. So we follow the same rules as before. We take the normal derivative, and then we take the derivative with respect to time. Let's take the derivative again, so the second derivative. The right side of our equation is a function of two products, so we need to use the product rule from calculus. The product rule says the derivative is fg prime plus f prime g. So we have 0.15 sine theta multiplied by the derivative of g, which is d squared theta over dt squared, or theta with two dots. Then we add the derivative of our f function, which is 0.15 cos theta times theta dot, and we multiply it by the g equation, which is just theta dot. Let's look at one last example, which is a bit harder. When we take the normal derivative first, remember that we are taking the derivative of the left side as well. So in this case, it's the derivative of r squared. So we have 2r, and then it's multiplied by the time derivative of r, which is r with the dot on top. For the other side of the equation, it's the same as before. Take the normal derivative, and then we take the time derivative, and multiply it by the time derivative of theta. Then we can isolate it for r dot. Now we will take the derivative of this again. The left side is once again a product of two functions. So we need to use the product rule. First, we have function f multiplied by g prime, which means it's r multiplied by the derivative of r dot, giving us r with two dots. Then we add the derivative of our f function, which gives us r dot, and then multiply it by the g function, which is r dot. The same goes for the right side. Treat that side as a product of two functions as well. So first, the f function is multiplied by g prime, which is 4 cos 2 theta multiplied by theta with two dots. Then we add f prime multiplied by the g function, which means it's negative 8 sine 2 theta multiplied by theta dot, and then again multiplied by theta dot. Now we need to isolate the equation for the second derivative, or r, with two dots. That's pretty much it when it comes to doing time derivatives. So you take the normal derivative and then you take the time derivative. If you have any questions, please comment below. Thanks for watching and good luck with your studies.